let's begin. There will probably be a few more people dropping in, but they will have to drop in when they come. So welcome everyone. I'm glad to see that there's been quite a few who have registered who haven't been to Compular webinars before. Today is a little bit different from what we normally do. If you've been to our prior webinars, we thought it would be very interesting to bring in a panel of experts, not all modeling experts, but experts in various aspects of R&D with a focus on electrochemistry on batteries. But today's discussion will not only be limited to people who are involved in that area themselves, but it should be more general and possible to follow for anyone. So to begin with, if you are new here and you might not know who we in Compular are and what we do, we're a Swedish startup based in Gothenburg, based off of research from Chalmers University of Technology. And we help R&D teams in liquid formulations to speed up their work by using simulations and AI. And that's the extent to which I will beat our drum today. Myself, my name is Rasmus Andersson, and I did my PhD at Chalmers University of Technology and was part of founding Compular 5 years ago. My main background is in molecular dynamics, other molecular scale modeling. I've also worked a little bit in different aspects of AI and software management. And today I am a CEO of Compular. So the reason that we're having this event is that obviously we believe a lot in the potential of modeling in industrial R&D. That's why the company exists. But we've also seen in our own experience and when talking to different people in the industry that there are a lot of ways to go wrong with modeling as well. We've seen many different failure modes where there's been some exaggerated promise from modeling, which it hasn't delivered on, or it has been applied in ways that don't quite work. And another reflection is that when we approach potential customers, there's a quite big fraction of them that are pretty skeptical to modeling altogether, or that for whatever reason don't use it a lot. That might be for good reason or it might be for bad reason. So we've thought a lot about this. We also actually published a short course that you can download in PDF format or get as an email course if you scan the QR code to the left. But we also wanted to have a broader discussion with some experts in the field in order to get more organic kind of coming together of different perspectives in this area. So with that, I would like to welcome our brilliant panelists. And before we go that, I will just mention some practical notes. So the only people who will speak in this conversation is myself as moderator and the panelists. So if you're someone else, please keep yourself muted at all times so we don't get any disruptions. The panelists, you may mute when you're not speaking or that's up to you. But I will give you the word, and if you want to request the word, you will use the raise hand icon. So that's in the middle to the bottom there. And then for the audience members, if you would like to bring questions, we have the Q&A function. This looks like a purple question mark in a circle, and it's somewhere up and to the right. So if you in the audience have questions, you can write something there. You can see Harish's example post there. So you can start doing that in the middle of the panel talk. And then you can also look at what others have asked and upvote if there is a question that you would also like to see asked. When you do so, you may choose who you address the question to, or you may just have it be an open question to the panel, depending on what you prefer. I think that was all on the practical side. Yeah, so just structure-wise, we will start with a panel conversation just with myself and the panelists. And that we will do for the first 40 minutes or so. And then we will open up for the Q&A section. So without further ado, we will go into introducing our panelists, which I will let them do themselves. So I would like to start with Anna Teiso. Why don't you unmute yourself and tell the audience of your experiences and background with an emphasis on modeling and industrial R&D.
Sure. Thank you, and thanks for having me today. So I actually built most of my career around batteries. I have a PhD in solid state chemistry. Back in 2005. And then I was lucky enough to enter Renault in a moment where the electrification was starting. So it was kind of having a front seat throughout this transformation. A lot working in quite agile organization. I won't talk about startups when we talk about Renault, but still it was a sort of e-power train engineering where decision-making loops were small. And so that was really interesting. And the suppliers were transformating. So I was in charge of supplier strategy. I would handle RFQs. And I visited maybe 40, 50 gigafactories at that title, and mostly in Asia, Korea, China, above all, and kind of looked into how to push these approaches from the portable electronics reference into the automotive standards that were very different. So I had a chance to live all that. And then I more recently moved into business, corporate VC, so investments, and then joined the Vercor. This is also another very different experience, and setting up to be a battery manufacturer in Europe. And essentially, I left Vercor quite recently to join a venture capital firm, and so now investing again in startup. So that's me essentially.
Mm-hmm. Yeah, that's a very diverse and interesting kind of standpoint, both from being in what would be the customers of this kind of technology. It may or may not be to the extent that the modeling providers think it should be, but you would have that kind of end user perspective of it, and also the investor perspective. I think is a very useful lens in addressing this area. So with that, I would like to give the word to Reza. Why don't you introduce yourself?
Sure. Hello, everyone. First, I apologize that I have lost my voice a little bit since a few days ago. And thanks to Rasmus for having me here. So just to make it clear, probably if you look at the title, it says the good, the bad, and the ugly guys. I think I'm the bad and the ugly one because I have almost no or very little experience with computational chemistry and modeling. So I'm not the expert in this topic, but I guess Rasmus wanted me to be here to discuss a little bit from what I have seen from experimental point of view, what I've seen when we talk with people expert in computational chemistry and modeling. So I did my PhD in Uppsala University, and I've been working with batteries for now 18 years. Started with my PhD in Uppsala, then postdoc at DTU, Technical University of Denmark, then came back to Uppsala with faculty positions, and then since last summer, I'm a professor in material chemistry at Uppsala University. I'm part-time working at Uppsala University and part-time at industry. So what I did around 3.5 years ago, I left academia partially, and I started working at a company called Novo Energy, which was a joint venture between Volvo Cars and Northvolt. And the aim was to build a gigafactory in Gothenburg, in Göteborg, here in Sweden. And to me, this was the reason for me was that to see how the real world works. We have been working with batteries in academia and research level, but I wanted to experience the reality. So things went wrong and south for Northvolt, as you probably know, and that affected Novo as well. So since summer last year, we moved to Volvo Group, which is a completely different company than Volvo Cars. So now I'm leading a team working on battery materials, future battery materials at Volvo Group. And also one of the founders of a company called Altris, developing sodium-ion batteries since almost 10 years ago. And nice to be here. Thank you.
Yeah, so what's very interesting about you, Reza, is that you've really seen, as you said, like you took the step from academia into the real world, and you've done that like in essentially like 3 very different organizations, even though you brought most of the team in between Novo R&D to Volvo Group. But now you're starting to experience the big enterprise culture as well, and where the financing environment is very different if you're doing a research project or if you're in Volvo Group or if you're trying to take Altris to the next level. So you would have a very clear perspective from you could stand to benefit from modeling, but maybe you haven't. And then why is that? That's something that I would like us to explore in this panel today. So I would like to give the word over to Alejandro. Please take the stage.
Thank you, Rasmus, for having me here. So good morning, everyone. And yes, I'm Alejandro Franco. I am a physicist. I did my studies in Argentina, and then I did my PhD in France, in the Atomic Energy Commission of France in Grenoble. And now I am a full professor working at the University of Picardie-Jourdain in Amiens, near Paris. I'm also, since last year, affiliate professor at University of Washington in Seattle. And I'm working in the field of modeling of electrochemical energy devices since more than 24 years. My expertise revolves around multi-scale modeling and AI applied to this kind of devices, and in particular batteries. And one of my major interests is the modeling and AI-driven optimization of battery manufacturing processes. This is my core research activity nowadays. So I'm working in collaboration with numerous companies, industries around these battery production topics. I'm also collaborating with actors of course, in Europe, but also Asia, North America. And I am also the co-founder and CSO of a young startup that was created last year, iChemix, leveraging more than 14 years of research on the topic of battery manufacturing modeling to be transferred to the industry sector. Yeah, so basically I'm also involved on several networks, including the French network on electrochemical energy storage, and including Alistor, which is a little bit the equivalent to the French network at the European level. I think Reza is part of it. Rasmus, you were also part of it, right? It's a very famous European network dealing with batteries. Yes, in my group right now, so we are about 25 people working mostly on these battery manufacturing digitalization topics. Yes, well, this is basically what I could say. I don't know if you have other questions. I will be glad to answer them. Thank you.
Yes, so we will definitely have other questions, Alejandro. So just the reason why you fit in this panel, I think, is pretty obvious. You've done a lot of different kinds of modeling, and you've mostly done them in academia. But then you've also decided recently to take the step out and try a business venture as well, built on this modeling. So I will be very curious to hear more about that later, which I think a lot of other people would as well. So from Alejandro, we'll move over to the fourth and final panelist, who presumably also is someone who believes in modeling, Henrik Ekström. The floor is yours.
Thanks, Rasmus, and thank you for having me here. Yeah, so I'm Henrik. I got my undergrad education at Uppsala University in Sweden, where I did stuff in the field of computational physics. And then I moved to KTH I don't know, 20 years back, 25 years ago, to get a PhD in applied electrochemistry, chemical engineering. And then once I got my PhD, I actually started working for 2 different startup companies dealing with fuel cells. My PhD was on PEM fuel cells. So I did that for a few years, and then I got an offer to start working for Comsol in Stockholm, where I work as a developer in the field of electrochemistry. So Comsol is a company that makes the software called Comsol Physics, and my elevator pitch for that software is that Comsol is for engineers and scientists what Microsoft Excel is for accountants. We compute stuff. In particular, space-dependent modeling is our field. So basically, you bring your CAD drawing and we add some physics and equations to that geometry and compute stuff for you. So that's what we do. Yeah, I think that's it from my side.
I'm very happy to have you as well, Henrik. Yeah, let me know if this is, because I know you've been quite a while at Comsol, but I know that it also has a long history before you joined it. So let me know if this is a bad question to ask, but could you give us a little bit of an insight into like how Comsol got started from a commercial perspective? Because as I understand it, it was more emphasis on academic users early on, and over time it has shifted to more of an industrial solution.
Yeah, well, I wasn't here at the company at that time, but originally Comsol did some completely different things within medtech, actually. And then the guys founding the company found out about this software called MATLAB and became the distributor of MATLAB in Sweden. And initially, of course, at that time, this was in the early 90s, 80s, or whatever, they built up a customer network and with people in Sweden dealing with computational science. That was most academics, of course, at that time. But then they also started to develop in-house code, which became eventually Comsol Physics. So I mean, gradually, we have shifted the customer base, I would say, from initially 100% academia, I guess, to more and more industry as people have graduated from academia and they bring these tools into the industry that has built the customer base. So these days we still have a stronghold in academia, but also the industrial customers are very, very, very important and add most of the income and revenue of the company as well.
Do you have a rough estimate of what fraction of income is from industry today?
I think I have, but I don't think I'm allowed to tell you. So.
Okay, yeah. So the basic mechanism, if I understand it correctly, was that like all of the initial users were academics, and it's not so much that it matured into industry, but more so that the users kind of transitioned into industry, and that was the way.
I guess so. Yeah.
Yeah, and do you think it roughly solves the same problems for academics as it does for industrial users?
In a way, yes, but also no. I think in academia you're more into some fundamental science and really want to understand how things work. Yeah, in industry it may look a little bit differently. Sometimes you just want to get some results. Yeah, to be frank, I mean, if you're in a startup company, you may actually only want to produce some very nice, colorful slides and pictures that look very impressive to investors, so to convince them that you know what you're doing. And whereas if you're in a larger industrial company with a large R&D department, you may do different things, right? You actually want to know how your things work, and in particular why they don't work sometimes, right?
Yeah, so I would like to turn to Alejandro. So you've been, as I mentioned, like you've been spending your whole career essentially in academic modeling, and then just recently took the step to found a company, and as I understand it, it is doing modeling and helping industry, but from a startup rather than from a research group. So could you tell us a little bit more about what made you take that step, and how do you see the difference between what industry needs compared to, yeah, what's viable in academic modeling?
Okay, well, first of all, I was not working in academia for 24 years, right? Because for 11 years, I was working at CEA, the Atomic Energy Commission. And this is not really academia, right? It's a national lab. So I would say it's in between academia and industry. So therefore, it's a different kind of mindset, even though I was doing a lot of academia-like research there, right? Because work related to modeling and so on, but with some engineering focus. Let me tell you a story in the following. Let me answer your question in the following way. I will specifically speak about battery manufacturing. Okay, even though I work a lot, as you know, so in other battery modeling related topics, right? The first time I submit a project proposal to European Commission on this topic on battery manufacturing modeling was in 2014. And this was a multi-partner project. I was the coordinator involving companies such as Siemens and Saft. And the project was rejected. And I still have the reports of the referees. And the reports, in the reports you can read that, okay, we don't need any modeling, for, optimizing battery manufacturing, because we already know how to manufacture batteries in Europe. 2014. So then this actually, pushed me to, to knock the door of ERC, the European Research Council, which actually is a, very famous organization to, to fund fundamental projects, right? Low TRL, high risk, high gain. And then I got the funding there, And then the modeling of battery manufacturing was considered, a fundamental topic, right? Very fundamental topic. And I was, as a physicist, driven by scientific curiosity, right? That's why I really wanted to explore how, a powder becomes an electrode, and then how this electrode then performs in a cell, right? I really wanted to develop a theory to link these three stages, right? Powder, electrode, and performance. But everything starts from a fundamental perspective, right? From fundamental curiosity. Then I got this ERC Consolidator grant, then a ERC proof of concept, and through the ERC proof of concept project, I start to, to explore ways to transfer all these batch of models that we develop to industry, because I received more than 100 expressions of interest from the battery industry sector. From Asia, from North America, also from Europe. And then I say, okay, the work we are doing in my lab, is, I would say, academia work, right? In the sense that we target low TRL. We are very lucky. We have a pilot line in the lab, right? So we have a small factory of batteries that is very nice, because we can use it to produce the, the parameters that we need to calibrate the models, to train the AIs, and so on and so forth. So then I start to think about, okay, we need maybe a company that can do all the software engineering needed, with nice graphical user interfaces, and so on and so forth, to transfer this collection of 100 plus models that we develop into industry, right? In a customized fashion, depending on what these needs are. And this actually was the path towards the creation of this spin-off iChemics, right? It was a long journey. It took us 3 years, because you have incubations, you have also, well, I had a lot of support from CNRS with some incubator programs. And also you need to find the right business person, right? Very important, to have a very strong team, very complementary to the technical team. And I also want maybe finalize my answer, regarding the point about the team, because we spoke about Northvolt and so on. And maybe we can come back to that later, because I also have some stories to tell about this. But I really believe that, having a very good alignment between the technical team and the business person is very, very important. In terms of roadmaps, in terms of technical decision, of course, but also in terms of which kind of person you are going to hire for your company at very early stages. right? Because there are many companies, they hire AI people, battery manufacturing companies, they hire AI people, but then the AI people realize that they don't have enough data to deal with AI. And if you are curious to know why they are complaining that way, I can tell you later, maybe in a second question. I will put that in standby, okay? But I have very interesting stories to tell you about that, based also on my work as a consulting person of some European gigafactories. Yeah.
So if I understand it correctly, Alejandro, you really started, like you dived into this from scientific curiosity as a physics professor. And then the grant agencies told you, no, this is not industrially relevant. It's not needed. It's not mature enough, or whatever they were saying. This is fundamental research. But then when you got the ERC grant for fundamental research, then the potential customers or you end users of this technology, they reached out to you and said, hey, we actually want this. So
exactly
that's how it was.
The take-home message here is the long-term vision, right? I never imagined, when I started working on this topic of battery manufacturing digitalization, 2013, I started to work on this topic, that one day, so many companies, I'm speaking here in particular on battery industry for manufacturing, right, are interested on this topic, right? How much interest the community, is putting on this topic. I never imagined that, because I was fully driven by scientific curiosity. So I think it's a question of long-term vision. So I'm very happy that now is the case. This research is having so much impact, internationally, academically, but also from industrial perspective. But yes, it's also a take-home message I like to share with the students. You keep doing what you like, okay, and then maybe one day that could maybe benefit industry or the society. But still, there are some challenges, right? I will share with you later if you want.
Yes, it's a very short question before we move on. Would you say that the TRL level is sufficient for industrial needs, or is there still a bit of a mismatch where they want what you could be giving them, but there might need to be more development in order to actually get there?
Yeah, sure. You ask, yeah, sure. I mean, there are some TRL is also a very important consideration, in particular when you are working in academia and you are trying to figure out what is the the border between your academic research and, I would say, the industrial research, right? As a professor working as a CSO, in academics. So yeah, I mean, to me, the clear distinction is can be established very clearly with the TRL concept. And so what is software engineering for customization for the industrial needs is the job of the company. What is exploring new methods, creating new methodologies, new models, working on how you calibrate, you validate, you make sure that the physics that you take into account in these physics-informed AI systems that we are developing and so on makes sense. This is the job of the lab, right? Because this is a very young and small company, right? Of course, if you are a big company, you will have your own R&D, internalized, right? Yeah.
So with that, I would like to move on to Anna. Why don't you tell us a little bit about your role at Verkor and how you related to digitization in general in development?
Sure.
What were your experiences? What options did you choose from, and what did you end up doing and not doing?
Yeah, so the company was really built around a few former Tesla people. Yeah, maybe a bit like Northvolt, but in their idea was doing it from scratch was the opportunity of bringing in a very, very strong digital backbone in the very creation. And I joined, we were 24, there was already a digital team. And so this, of course, grew in time and took a big importance. It was completely drastically divided in two activities, which had very little to do one with the other. One was everything about electrochemical modeling and helping the product team design the right cells faster and in a more efficient way. and the team was fully integrated inside the product team. So this intimacy was really key. And I have heard people in the product team say, okay, we arrived in the R&D line with our batch, the very first coating. The modeling team gives us a preferred slurry composition, and we're saying, you know what, we do it because that's what we do, but they had not yet the trust into it, and they simply said it was simply great. We avoided so much trial and error, additional loops. It was really quickening the work of the team. Practically speaking, it was fully building trust because of the efficiency, because it was not making people lose time. So it's really based on these practical results. And then the digital team is something else entirely. It's something that is very related to the process preparation. So it's all about anticipating. So if it's in the backbone of the company, it means that when the RFQ go out for equipment makers, you have specified very precisely the level of communication and data format transfer accessibility, which is always part of a huge negotiation, because equipment supplier prefer it to be a kind of black box. So having access to those kind of parameters is essential before the supplier is actually chosen and named, and this is the only way to get to it. And also some suppliers or countries are make it more difficult to have access to this, and so Verkor did not go to the less expensive solution, but sometimes chose those that could accept to have this kind of contribution. And so this was really super important at the time, which is super early when you are buying the equipment for your pilot, and then usually you want them to be the same in the core processes than the ones you will choose in the Gigafactory. So that was really an important stage. The second point that was really really helpful was to train the models, the approach through the pilot line. Very frankly, I don't think that this is done, at least even the Samsung, LG, etc. Out there. There are very little battery makers that really have this overall thread that goes from the very batch number, and this is our pilot line cell number, and with their battery ID, etc., and a coherent set of data that goes through every single step of the process at pilot line stage, which is very early. It's like a production capacity that is not 1 giga, so it's something like 0.2 giga, for example. So this is an absolute great way to and this is also a bit linked to the story of Verkor, having to supply the customer from the pilot line, because this was the agreement, and so you kind of put the standard of traceability, pushed it back into the pilot line. But this is obviously a whole training thing. It doesn't mean that you will not find a lot of difficulties, hurdles, and things won't work, but at least you're testing this and stress testing the approach and the accessibility, etc. What on the other side is very difficult is that there are potentially a huge amount of value optimization unlocked rolling out innovations in the process that are possible because you have this access to digital data, and I mean actionable digital data. It means that it goes throughout all of your process, all of your workshop, and that you can take decision based on something that happened just a few workshops away. So this is possible, but it's very difficult to implement these innovations during ramp up because of course you have other priorities, etc. So there's this huge potential. There's still a bit of a feeling that it's still untapped. You need to go through the ramp up, successfully deliver, get out of this stressful tunnel before the things go well, and then you can start optimizing on that. But a few of the ideas I saw were really potent in the sense of kind of overall optimizing and adapting the process to what happens a few workshop away, but you will not implement them for the first time. You never have time. That's a bit of the challenge.
But did you get the sense that both of these kinds of digitization efforts really bore fruit? Is that?
Yeah, and I do think that it makes a difference. Well, I was in charge of the relation with the OEMs, and I think that having this kind of traceability, and you can live show it on a computer and say, okay, look, take this cell, let's look what I have in terms of information related to it is really impressive. So it can really help to make kind of differentiating point for customers. And definitely it's just impossible to think about doing that at gigafactory level if you haven't tried at pilot scale. So that's really a huge asset. And to be very frank, the way it works in most of, I know that a huge lot has changed since 15 years ago even, but the way that people felt the automotive standard to be is just collect the data and not throw it away. And if there's an incident in the field, then you can kind of go back and say, okay, this is the data related to that cell. But this is a very different thing to have access and keep 20 years of data, have the right servers, etc., and have the right and to go back and understand what happens 2 weeks later. This is completely different. It's of course it's what automotive standards require, but it's very different than having actionable data, meaning a few minutes later you already take decision based on the process parameters to cut something that has a defect and without stopping the process, for example. This is entirely different in terms of accessibility.
So has this generated any shift in your understanding as an investor now when you're looking into either modeling or AI or digitization generally kind of solutions, or as well when you're looking into the next batch of ambitious hardware or like manufacturing companies in the energy space? How do you think about modeling and digitization in that?
That there's a real conviction that there's a very high value that can be addressed by these approaches. There are situations that are absolutely absurd. That if you take just the manufacturing process today, you have 1 to 3 weeks of cells just waiting there into some vertical stacks during formation. You're just waiting for a voltage to drift, and that's your quality check. It's extremely ineffective in terms of footprint and capex and everything that it represents. So if you had a way of modeling just after manufacturing, having the right data to determine what cell have potentially a microcircuit, those who don't, and having an actionable diagnostic moment in the quality check would be really tremendously huge as a value. Or I take another example I was mentioning before, having actionable items. It's just simply without actionable, just not going into ramp up blindfolded, but seeing by the process data, you can do so much. I mean, machine learning and detecting and correlating. So as an investor, actually, I think the field is huge. The real difficulty that I recognize within all of the startups is access to field data, access to, and I was mentioning trust in the when I was explaining, even within a company, there are some trust barriers to be broken when you have a modeling team telling a product team what to do. So if it's an external startup, that it's really the challenging part. It's or when they tell me I have a much better BMS, all the OEMs have invested so much in amazing BMS teams, and this takes like 50 people if you want to do it right, and you're not seeing very easily somebody else challenging your BMS team with something different. So it's all about kind of access. The scale is potentially huge, but access that enables the scale to happen is so it's all about the right business model that makes it easier and doesn't externalize a risk, because you also have liability issues. So yeah, potentially the value is huge, but the access is always the tricky part.
So essentially, we've heard a lot about the good of modeling and a little bit about the ugly friction points. But I'm curious, Reza, maybe you have more to say on the bad side of modeling, or not. We'll see. What do you think when Anna describes how much it helped them in Verkor, and how do you relate to that from your experience?
I start to be positive. I start with the good part. I think to connect to what has been discussed so far, what Anna and Alejandro said, I think this makes sense a lot. When it comes to production, of course, collecting data is very valuable. That could be useful in the future. But if you look at the production, it's very much physics-based phenomena. The same is in research. That's what I have seen last 15 years, that if there is anything related to physics and physical reaction, etc., computational and modeling is very, very helpful. So on the cell level, if you're after, for example, I don't know, thermal responses from the cell, or if you look at the cell as a black box and you want to collect data and use that data, this is very valuable, and I have seen lots of good work from many good people. The ugly part that I have seen a little bit is when it comes to detailed chemistry and electrochemistry, that sometimes I have seen that people ignore the fact that when you go into the cell, there could be hundreds of different reactions happening at the same time. So if you're after picking up one reaction and do modeling, ignoring the rest, the conclusion could be really misleading. And that's the ugly part that I have seen. There are, of course, physics-based phenomena inside the cell that you could do computational, and that could be helpful. If you're after, for example, ionic conductivity of the electrolyte, modeling could be very helpful. And this is something that I guess, Rasmus, you guys are doing. So you can play with solvent-salt chemistry and calculate ionic conductivity, and you can potentially be much faster than experiments. But my point here is that ionic conductivity is just one parameter out of 100 different parameters that you need inside the cell. So by concluding that one chemistry is better than the other chemistry, sure, that's very good a step, because you want to have better ionic conductivity, but one needs to be very careful that there are many other parameters that could actually be in reality more important than ion conductivity, just as an example.
So this actually connects quite naturally to one of the questions that has been posed by the audience, and I won't read it out verbatim, but essentially AI, of course, is on everybody's lips these days. And to me, AI is a different kind of modeling, and there's often complementarity. And this seems also to me to be more closely related to what Anna described for, like getting all the data in and having it be actionable. I'm guessing that AI is a part of that, or could be a part of that. So perhaps we'll just go around the table now and just have everyone say a little bit about how do you think about AI and how it relates to the more physics-based modeling approaches that both COMSOL and Alejandro's group have focused more on. So yeah, you'll get the word first, Alejandro.
Thank you.
You're very silent now.
Okay, can you hear me?
Yes, lower than before. I don't know why.
Okay.
Okay, but this is
now it's better. Okay. Yes, I truly believe physics must be in the core. Okay, physics-based modeling must be in the core. I was invited to a roundtable in Seattle, 1 week ago. The roundtable was chaired by Microsoft, and we were actually discussing the same thing, AI versus physics-based modeling, right? And the role that AI plays in industry versus physics-based modeling. And basically what I can say is that when industry comes to me, to collaborate and so on, they come because of the trust, right? Trust from the fact that we have a very strong physics-based background, right? Even the AIs that we develop are physics informed. We try at least to develop AIs that are physics informed, that can be used to, extrapolate, beyond the parameter space that have been used to train them. And also that can be used to provide also some explainability, right? And I fully agree with Reza, about that. It's not only about, having, I will say, a fully data-driven machine learning model, it will be useful to start to get a guess of how input parameters correlate with output parameters, right? Manufacturing process parameters correlate with the properties that you want to optimize. But this is not enough, right? When you want to shift, for example, the chemistry type, you want to use to prepare your slurry, for example, to make the coating, you will realize that you will have problems with coating heterogeneity, and then you want to understanding the reasons of why this is happening is very useful for the engineers or operators to optimize the process faster. And it's not only about AI alone, right? It's also physical understanding also can be a great accelerator of the optimization process, right? So then I truly believe in the hybridization between physics-based modeling and AI, right? Because there are pros and cons in both sides, right? In the physics-based modeling part is sometimes the computational cost. In the AI, of course, you can simulate faster, but you lost this physical sense if you move to something fully data-driven. So therefore, combining both is essential. And let me maybe connect that point with a last point, Rasmus. It's a little story, it's coming from my interaction with some, gigafactory companies. And I think it was more or less aligned with what Anna was saying. You might find people doing AI, in battery industry for sure. But usually, they complain about the lack of data, especially the young startups, because they don't have enough time. I would say the operators, right, don't have enough time to perform failed experiments. You see what I mean? In academia, we have plenty of time for doing that, right? Because we want to understand the reasons of failure, right? So then we will create data sets which are very, heterogeneous, right? So that means electrodes that they have a lot of cracks, coatings with very poor quality, cells that are eventually, failing after, some doses of cycles, right? We want to actually develop, have this kind of data in order to understand the reasons of failure, right? But in some startups, I was discussing with, as soon as you have the operator that finds, the right recipe, that allow them, to provide to produce an electrode with enough quality, they will move forward, right? You see what I mean? So then your data set become narrow, and then there is no enough variability to have an AI that can, afterwards, be used for optimization, right, and for inverse design, right? So this is, I believe, is also a practical bottleneck that is can be found also in industry. From my perspective, right, from what I could also sense, from my interactions with them. But therefore, then I truly believe that physics is in the core, definitely. Yeah. So this is, and I also don't believe that AI agents will, make multi-physics simulations obsolete. I really believe this is a complementary tool, right, that really helps software engineers developing codes or developing models. But yeah, and this relates to another point that I can discuss further later if we have time, is education, right? Education, keeping critical thinking, right, for the young generation of engineers, right, both at the experimental side and also at the modeling side. Not fully relying on what are the outcomes of AIs, right? Black box AIs. I mean, having critical thinking in the loop, human critical thinking, developing methodologies to have critical thinking in the loop is crucial for the generations to come. Yeah.
Yeah, I fully agree with that, Alejandro. I mean, let's say, for example, you're using ChatGPT, you will see that it will use Google search or it will use a calculator or something. I think this is the same thing. But I will hand over to Henrik quickly and ask if you are integrating AI into your work or seeing anything in how the community is using Comsol together with AI.
Yeah, I don't know if I have that much experience really, but I mean, just to get back to what Alexander was saying there, I would think, I personally, I believe in this concept of physics-informed AI. When you make a model, there are always things that you don't know, like kinetics parameters. As Reza said, you can have 100 different edge interactions that you need to consider. Maybe it's beyond the point or scope of a model to actually describe all those, and then an AI trained part of the model could be a very good complement, I think, to. But you, sort of, I think what this AI, what to get with an AI is a black box, and you lose understanding of the actual problem that you're actually facing, and that goes into the education, but also into design. I often notice that, but I've been working on a longer modeling project, setting up a new tutorial model for Comsol. I realized once you compile all the equations, set up the problem, look into all the parameter values, you don't even need to press compute really if you actually understood what you were doing, because they already know what the model will tell you, and that's actually the modeling process brings you some kind of a human insight to the actual problem that you can live on later on, when designing other types of stuff. And if you switch to AI models, you completely lose that whole process. But of course, if you are to design a simple state of charge estimated for a battery in a small device somewhere, maybe an AI model is completely sufficient, and there's absolutely no point in going to physics-based modeling. So I think these two methods will complement each other, but we are not really that worried at Comsol about this. We have tools for integrating neural networks to create surrogate models that you can use as input to the more complex multi-physics model, physics-based. So we're looking into these tools, of course.
Is this internal tools or user-facing tools?
No, we released already this, but we don't call it AI. We call it surrogate models, but we have those neural networks.
Parameter fitting.
Yeah, exactly. Basically, advanced lookup tables for fast data access for large experimental data sets. So yeah.
So I would like to ask a question from Jing Yi to Reza specifically. So do you think the bottom-up approach to build a cell from materials level is useful for OEMs like Volvo Group? And what challenges do you see in this approach?
Interesting question, and this is very complex. I can't talk about it until tomorrow. But one aspect I would say that you could say yes, if you have correct vision, similar to what Alejandro said, if you have correct vision and critical thinking, you could design things from bottom up, and then you can be competitive. That's my vision, at least for Europe, especially that we are behind Asia. The reality, however, is different. The reality is that we don't have battery industry in Europe ready. So this type of design and revolution and improvement, that if you look at what we have been with Altris, we started sodium-ion batteries 10 years ago. No one wanted to talk with us. No one believed in Europe. No one. But today, everyone is interested. Why? We are still talking about the same technology, same material. Everyone in Europe now is interested just because China has moved in this direction. So the same goes with Alejandro, that maybe all this suggestion that he has, people might be interested, but in reality, this doesn't work in short term, because those type of suggestions could easily work where you have established industry, and that established industry is ready to take risks, to take the next step. But the reality in Europe is that everyone is so scared of even the first step. Can we manage to take the first step? If we take the first step, then we will think about other concepts. So difficult question to answer directly. It is yes. The answer is yes. I would say that's the way to be competitive. That you design things from bottom to top, whether it's material or processes. Then you can be competitive. But the reality in Europe today is something different. I mean, that vision would work.
I'll need to cut you off there, Reza. I think it was a very well-reasoned response. And I will allow Alejandro to just give a quick comment there, which will likely be the last we have time for in the panel.
Well, no, thank you very much, Rasmus. I think...
Oh, since we lost... we lost Alejandro just when he was going to give a answer to that. Okay, so I realized that the time struck 1. I don't want to keep any of our panelists or audience members any longer, but thank you everyone for joining. Thanks a lot to the panelists for doing a brilliant contribution. And yeah, I wish all of you to have a good day. And if you are interested in anything about modeling, you can feel free to go into our webpage and see what we are doing, or you can visit Consoles or iChemix or Exergon's website for that matter, or Volvo Group.
Yeah. I'm sorry, I had a problem with the internet, but okay. So
okay, yes, we have Alejandro. Okay, so for those of you who have another minute, feel free to give you the rest of your response. Alejandro.
No, I thank you, Rasmus. This is a very fantastic, event. Really, I really enjoyed. I think at the end of the day, we didn't have disagreements, I think, between the different panelists, but it's very nice, and I think it needs to be organized again. Maybe a last word is about education once again. Very, very important aspect. How modeling can help educating, the next generation of researchers, engineers, and so on. We should not forget about that. It's very, very critical aspect, in particular to develop methods that can help young generations to keep critical thinking, in the loop, right? AI is a fantastic tool for sure. We need to work with AI in a co-pilot fashion, I would say. Yeah, that's my last word. Thank you.
Yeah. On that brilliant note, we'll close the session. For everyone.
Thank you.
And have a good rest of the day.
Bye-bye.
Thank you. Bye.